Okay. Next part here is about the supernode. Supernode, which is something simple. Sometimes people get scared when they heard, okay, supernode. It's not something difficult. It's very easy. Okay. Assume that you have this example where you have a source like this 10 volt between V1 and V3. Okay. So in this case, you cannot write equation for this current, the current in this branch, because you don't have resistor. Okay. So what's the solution? The solution is like this. You have two steps. Step number one is that you write the equation or the relation between these two nodes. This super node or this voltage source is between V1 and V3. V1 and V3. So it's very simple to find the relation between them. Of course, in this case, the positive side is V3 minus the negative side, which is V1, equal 10 volt. V3 minus V1 equal 10 volt. That's it. So this is the first equation. Okay, so we know here that the positive side minus the negative side equals the source. So V3 minus V1 equal 10. Or you can say V3 equal what? Equal V1 plus 10. You can say that also. So it doesn't matter. Any way you like it. So this is the first equation. Second equation, you do it like how you do it. You merge the two nodes. So imagine that these two nodes are combined together, or one node. That's why you call it super node. So now you see, it says in purple here. So all these are is one node. This one is one node. Okay. So now you write equation for this super node. The super node is connected to how many branches here? 1, 2 from this side, 1, 2 from the other side. Then you have four currents connected to this super node. Of course, you don't have a current inside here because this is inside the node. You don't need it. You just need to calculate the currents exiting this super node. So it is 1, this one here, plus this one, plus this one, plus this one equals 0. And all these currents are so easy. Like this one, for example, is V1 over 4. This one is just V1 over 4. This one here is V1 minus V2 over 2. This one here is V3 minus V2 over 2. And the last one, V3 minus 0 over 8. Then this will be the second equation. So here at the super node, we have two equations here. The first one is the relation between the two nodes, V1 and V3. So V3 minus V1 equal 10. Or you can write it different way as you like. And the second one is when you merge these two nodes and apply Kirchhoff current law as normal. So this current plus this one plus this one plus this one equal 0. Then of course we have this regular node. This regular node you apply Kirchhoff current law as this node. So the first current is V2 minus V1 over 2. Then V2 oh no, sorry, this one V2 minus V3 over 2, and the last current is negative 5. So this will be the equation at node number 2. Now you have three equations, 2 for the super node and 1 for node number 2. You solve them and find V1, V2, and V3. After you find V1 and V2 and V3, okay, now can I find the current in this branch? Yes, of course. Okay, but you can't find it or write equation for it using Ohm's law or whatever. How can you find the current here? For example, assume that I need the current. I want to calculate this current here. For example, okay, let's call this IS, whatever here, IS. So according to this, IS equal what? IS equal the two other currents set. This IS is like this. Okay, so you have IS is this current here. So equals this one plus this one. This Kirchhoff current law. So this IS equal what? Equal this current plus this one. Let's see. So IS equal what? Equal the first current is V1 over 4 plus Second current is what? Is V1 minus V2 over 2. Okay, so this is a current. You calculate it. You know now what's V1, what's V2, what is V3. We have them already here. Okay, so let's see if we calculate this. What's the value? We'll see it. Okay, so let's see, for example, here. V1 divided by 4. V1 is 10, is given here. So look at the values here. V1, V2, V3. Okay, so let us see. V1 is 10. 10 divided by 4 equal 2.5. Okay, 10. So this is 2.5. So let's write it here. This is 2.5 plus V1 minus V2. V1 is 10 minus V2, which is 20, divided by 2 will be negative 5. So it will be plus negative 5. Equal what? Equal negative 2.5 ampere. And it's okay to be negative. There's no problem with that. So this means what? Means that IS actually is not in this direction, IS in the other direction, and it is positive 2.5 in the other direction. Okay? So let us see, for example, can I calculate IS in a different way? Yes, of course. Yes, of course. So if we look at node number 3, node number 3 look like this. So you have IS. This IS is in this direction. This one. This is IS. Okay, because IS is moving like this, moving. So here it is. So this is IS that I just calculated. So in node number 3, it is going up. In node number 1, going down. So this current equal what? Equal this one plus this one. Makes sense? So you have two currents add together to give you IS. So again, in this case, IS equal what? IS equals the first current. This current here, the first current is what? Is 0. 0 minus V3 divided by 8. 0 minus V3 divided by 8. So 0 minus V3 divided by 8, because the current is going up. The current is going up. Plus, second current is going from V2 to V3. So it will be V2, which is V2 minus V3 divided by 2. Okay. And now if you want to calculate this, okay, let's use other color. V3 is negative, is 20 volt. So it will be negative 20. V2 minus V3 is 20 minus 20 is 0. Okay, so this one is 0. So it will be negative, IS is negative 20 divided by 80. Negative 20 divided by 80. So 20 negative divided by 80 is 2.5. Negative 2.5. The same answer. Same answer. So this is how you find IS. Let's look at this example. Here you have two nodes. You have V1 and V2, and this is the ground. So you need to write equation at V1 and equation at V2. At V1, this current is negative 3 milliampere. Second current is V1 minus V2 over 4 ohm, 4 kilo ohm. So this is the first current and second current. So this one is the first current. The second one is this one here. Let us look at the third current. The third current is this current here. Okay, you have this resistor, then it is V1 minus the voltage here over 2K. Over 2K. So what you need to do is just find the voltage at this point here. Of course, if this is a voltage source, If this is V2, this one will be what? Will be V2 minus 3V0 because it is in the negative side. That's it. If this voltage is V2, this one will be V2 minus 3V0. That's it. So this is what you need to write here. It is V1, the current equal V1 minus the voltage here, which is between bracket V2 minus 3V0 over the resistance, which is 2K. Then this is the first equation. Second equation will be easier now. Why? Because we already calculated the current and this current. So for example, what is this current? This current is opposite. So it will be in this direction. So it will be this one here minus V1 divided by 2K. So it will be this one here. V2 minus 3V0 between bracket minus V1 over 2K. Second current, which is this one here, is V2 minus V1 over 4K. V2 minus V1 over 4K. And the last current is this one here, is V2 over 1K. Okay. Then you need to get rid of V0. And according to this, V0 is just V2. V0 is this voltage minus this voltage. This voltage is V2. The one at the top is V2. So positive is V2. The negative is 0. So it will be V2 minus 0. So V0 equal V2. Then you substitute in the equations. And now you will have two equations and two unknowns, V1 and V2. You can solve them. Okay. So this will be this example. Let's look at this example. Here you have a supernode, of course, because you have this voltage source between V1 and V2. Then how can we find it? So to find it, as I said, first find the relation between V1 and V2. V1 and V2, one minus the other one equals the source. One minus the other one equals the source. So which one is positive, which one is negative? So again, to explain it, because maybe it is not clear, select, delete. So again, here it is. You have this source, okay, positive, negative, and you have two nodes. This is V2, and this is V1. Then the relation is very easy. The positive is V2 minus the negative, which is V1, equals the source. What is the value of the source? It is given here, 4I0. So it is 4I0. Okay, so this is the first equation. Very simple equation. Second, when you merge these two together, then now you look at this big node here and how many branches connected to it. So from V1 side, you have how many branches? Let's see. We have a current. We have this one here that has the current source, and we have the one that has 4 ohm, and we have the one that has this 1 ohm. Look like this, right? And from V2 side, you have two currents. You have this one, and you have this one. So here V1 is connected to 1, 2, 3 branches, and V2 has 1, 2 branches. Then you have 5 currents. First current is negative 1 ampere. So this current is just negative 1 ampere because you have a current source and it is opposite to this. Second current equal what? Equal V1 over 4 ampere, 4 ohm. V1 over 4 ohm. So this is the second current. Third current is V1 minus, I believe it is V3, yes, minus V3. V1 minus V3 over 1 ohm. Over 1 ohm. And this is the second current. A third current. From the other side, okay, what is this current here from V1? It is V1 minus 0 over 1. So it is V1 over 1, V2 over 1, sorry. V2 over 1. Second current is what? Is opposite to the current source here. This is a current source, and the value of the current source is 2V0. Then this current is 2V0. There it is. So now you have 5 currents. You add them together. This will give you this equation. So look at this equation. The first one here is 2V0. No, this not this one. Sorry. It is okay. You will not be able to see it. Okay, let's just try to. Okay, so let's make it like this. Okay, there it is. So you have -1, this -1, and then this current is V1 over 4, V1 over 4, and the third current, which is V1 minus V3 over 1, and then you have this current that is -2V0, not V0, -2V0, and the last one is V2 over 1, V2 over 1. So you have these 5 currents. This is the second equation of the supernode. Then you write equation at V3, which is very simple. For V3, this current is just 2V0 from V3 to V2. This current is just 2V0. This current here from V3 to V1, so it will be V3 minus V1 over 1 ohm. This one here is V3 over 4, or V3 minus 0 over 4. And the last one is V3 minus this voltage. What's the voltage here? Is 10 volt. So voltage here is 10 volt. So it is V3 minus 10 volt over 2, which is this one here. So now you have 3 equations. 2 at the supernode, V1 and V2, and 1 at V3. But in how many unknowns? Seems that we have 5 unknowns, because we have I0 and we have V0. So we now just need to get rid of I0 and V0, which is very simple again. There's no problem here. Where's I0? You look at I0 in the circuit. I0 in the circuit is here, this one here, right? This one, this I0. So it is V3 minus 0 divided by 4. That's it. I0 is V3 divided by 4. What about V0? V0 is the voltage across the 1 ohm, which is simple here because it is between 2 nodes here. So the positive side is V1, the negative side is V3. Then V0 equal V1 minus V3. V1 minus V3. So now you have V0 and I0 in terms of the nodes, nodal voltages. Then you can find or make it 3 equations, 3 unknowns, and you can solve them. Next time I will talk about mesh analysis.